Hello viewers, I do sincerely hope some of you have been finding my content useful. On the screen you will see a simple problem on differential equations. For those who are in the sciences, engineering and applied courses, you are most likely to encounter differential equations as you progress in your studies. So first, what is a differential equation? A differential equation simply is an equation which contains a derivative. I'm going to define some of these terms as we progress in this course. Now, it is important to emphasize that the solution to an algebraic equation is a number or a set of numbers, while the solution to a differential equation is a function. Take for example these two simple algebraic equations. The first one here is a linear equation, and in this linear equation we are told that 2x plus 2 equals 4. For this equation to be satisfied, x has to be 1. 2 times 1 is 2, and then plus 2, that will give you 4. While in the simple quadratic equation that we see on the screen, for us to solve the quadratic equation, as you all know, we look for two numbers that their product will give you 6 and their sum will give you 5. And those two numbers simply are 2 and 3. So this quadratic equation reduces to x plus 2 or x plus 3 equals 0. So the solution that satisfies the equation, x has to be either minus 2 or x will be minus 3. Because if x plus 2 equals 0, if you make x to be minus 2 plus 2 equals 0. The same goes for x plus 3 equals 0. If x is minus 3, you plug minus 3 here, so minus 3 plus 3 will be equals 0. Now let me quickly point out that a differential equation can have many solutions, which are called class of solutions, which can satisfy the given equation. In the equation that we are given, we are being asked to prove that e raised to power minus 4x is a solution to the differential equation. And this is the differential equation. So we are being told that this is one of the solutions. There can be other solutions. So remember our definition of a differential equation. For sure, this is an equation because it contains the equality sign. And we are being told that the second differential of y with respect to x plus 3 times the first differential of y with respect to s will give us 4y. Earlier we were told that a differential equation is an equation which contains a derivative. And for sure, this is a differential equation. What makes it an equation? Here we have the equality sign. And here we are being told that the second differential of y with respect to x plus 3 times the first differential of y with respect to x will give us 4y. So this equation contains differentials and it has an equality sign. So that makes it a differential equation. Before we solve this equation, we want to remember that this can be written in another form, like d square y all over ds squared plus 3 times the y all over the x equals 4y. And we also mentioned that the solution to a differential equation is a function, of which we were given one of the solutions to be e raised to power minus 4x. That simply means that y equals e raised to power minus 4x. So we'll now go ahead to prove that e raised to power minus 4x is a solution to the differential equation. And how are we going to do that? Please watch. It's very simple. Because we have an equation that contains the second differential and the first differential of y with respect to x, the first thing that we need to do is to look for the first differential. So the y all over the x is equals minus 4e raised to power minus 4x, while the second differential with respect to x is equals minus 4 into another minus 4e raised to power minus 4x, and that's equals 16 times e raised to power minus 4x. So we're almost there. Y is equals e raised to power minus 4x. Y prime, which is the first differential, is equals minus 4 e raised to power minus 4x, and y prime prime, which is the second differential, is equals 16 e raised to power minus 4x. So with the answers we already got, we saw that y prime prime is the same thing as 16 e raised to power minus 4x plus 3 into y prime is minus 4 e raised to power minus 4x. We want to find out if this is equal to 4 times y. Recall that y we were given initially is e raised to power minus 4x. So from here we just rearrange. e raised to power minus 4x plus and minus will give us a minus. 3 times 4 will give us 12 e raised to power minus 4x. And question is, is this equal to e raised to power minus 4x? So 16 minus 12 is 4 e raised to power minus 4x, which equals 4 e raised to power minus 4x. And we're done. Yes, we're only being asked to prove that the left hand side of the equation equals the right hand side of the equation, and we have proved that. Now recall we mentioned that a differential equation can have many solutions or class of solutions, and that is why the B part of the equation is asking us to suggest an alternative solution. If e raised to power minus 4x is one solution, we are being asked to suggest an alternative solution. Well, an alternative solution can be e raised to power x, and let's find out if e raised to power x also satisfy the given equation. Y prime prime plus 3y prime equals 4y. And we're saying that y can also be e raised to power x. If y is e raised to power x, y prime is also e raised to power x, and y prime prime is the same as e raised to power x. Yes, the first and second derivative of e raised to power x also gives you e raised to power x. So let's slot this into the original equation. Y prime prime is e raised to power x plus 3 times y prime, which is also e raised to power x. Does that give us 4 times y, which is e raised to power x? Of course, as you can see, e raised to power x plus 3e raised to power x is equals 4e raised to power x, and this exactly equals 4e raised to power x. We're done. I promise you I will break down every topic I treat to the level where even a kid can understand. I hope I was able to throw light on this aspect of differential equations. Please let me know your thoughts in the comment section below. To encourage me to do more, kindly follow this page if you have not done so. Also, please follow my other social media pages and YouTube channel. See you in the next video. Thank you for stopping by.